Yeah, now we can start.
Okay, for the third time again, very good evening to one and all of you. I hope you guys are all doing great and are as excited as I am in welcoming you all to the GIT session conducted by CTE. So now I'll introduce you to today's speakers. First is Hrishikesh Patil, who's a third year right pursuing Triple E. He's the current WebD lead in DevSoc BitScoa. He's also a two-time Google Coding finalist and is currently working as a backend developer at CryptoCase. The second speaker for the day is Pranay Varshney. He's also a 30 who's pursuing computer science. He was an ex-research intern at National Center for Polar and Ocean Research. He has also secured an SIP at Qualcomm. So now I'll pass the mic, the virtual mic on to these two speakers to carry the session forward.
All right. So thanks for that introduction, Gautam. And again, I welcome you guys. So I see a pretty good number, and it is a pre-requirement for the buzzword which has been going around with a lot of engineering students our age, which is GSOC, the Google Summer of Code. So first, let's start with a little bit of history. What is Git? So have you guys heard of this guy named Linus Torvalds? Not the guy from Linus Tech Tips, mind you, but the founder of the Linux kernel. If you have, you can just raise your hands and I'll get to see your number. Okay, you can see why. So, okay. So you guys have gotten your history, right? So Linus, Linus started Git as one of his side projects when he was working on the Linux kernel because Linux kernel was initially worked on by around 250 people, and Linus had to take care of each of their contributions in a completely organized way. So, what Linus did was initially they were using this version control software called BitKeeper, but the founder of BitKeeper somewhere down the line decided that it won't be available for free use anymore. So, Linus went ahead and pinned down a set of requirements for his own version control software. And the first, then came along Git, where the first version of Git was able to apply patches to the Linux kernel at a rate of 6.7 patches per second. So what are these words? Patches, Linux kernel, and so let me ask you another question again. You can type the answer in the chat box. What exactly is Linux? Those who would have taken OS before would be able to answer it in a more correct way. But what do you think Linux is? Okay. So I see open source OS, those, but not exactly correct. Any other answers? Okay. So Linux is actually a kernel and not the OS. Group of OSs, yes, that is. uh, So let's first bust this myth. Linux is not an OS. Linux is a kernel and it is one level below the OS. What Linux as a kernel does is it's a set of instructions in the way how you interact with your machine, and a lot of other operating systems are derived from Linux. Of course, you know the popular ones. There is Ubuntu, there is Kali Linux, then there's the cult which comes from Arch Linux. Then there are other smaller known operating systems. There is Fedora, there is Endeavor, there is CentOS, there are multiple operating systems. So when Linus developed Git and he's opened it out to public, people realized what the power of Git was. And how it can be used to track different versions of the Linux kernel initially when it was developed. So you see, the first you have to understand the size of a kernel. So you have a software which is around 20 GB, 20 to maybe less than that. Sometimes it's a few hundred MB also. But can you imagine 300 MB of text data, which is just instructions to the CPU that is running on your system, and then you had to track the changes between the version that was released maybe yesterday, maybe 2 hours before, half an hour before. So every time the 300 MB adds up, and you're going to blow up your storage in a pretty short amount of time. So what Linus did was he said, "Hey, you know what? We have 300 MB of code, 300 MB of code, but the changes will barely be a few KBs in size. So why not? Why don't we just store the changes between each file, and then once we look at the changes from one point to another, then we know how to get from say this point in history, make those changes at every point wherever they happen, and then come back to the current version of this file." This is something which you would have observed in cricket as well. So you see these big one-day internationals or even T20s. So there, you don't just have the current score of the match. You have the complete data of what over was what over is being played, what runs were scored at each ball, whether there was a wide, there was a four, there was a six, there was an extra ball because someone threw a no ball, etc. And that's how it works. So let's just see an example of version control. You may or may not have seen this document. This document is like- Some of you would have tried messing around with Google Docs, and you can see version control here as well. So if I press into a tab, then go here. So if I go to edits, and then you can see the versions. Once this loads, you can see over here what is highlighted, and these were the changes made by whoever had made those changes. So let's say I go to this point, January 14th, and scroll down, I can see how the document looked at that point in time. Then maybe if I want some major changes which were made initially. So if you see this sort of highlighting where I can over this, and I think the name comes up of who made these changes. So this is what version control is. Let me expand this. If I go here, so this is an example of version. You can see that there are different versions of the same document, and what we are doing is, if we go back to the initial state, let's see this one. So the way Git works is you don't store files as themselves. You always store changes in files. So every time you make any repository in Git, you'll always see that the first commit looks something like this: creation of the file. You don't have any contents or anything, and then the first changes come along. Yeah. So here you can see who has made these changes. Whoever it is. Mm, any. So this was how version control was handled in Google Docs. Now coming to Git, let's have a look at this website. So I will open up here and my login page. in the chat box. So those of you who are on laptop, they can follow along with me. Those of you who are more interested in just looking at it and you would want to follow from the recording later, you are free to do that as well. So this is a short website which I had come along, and what this does is, it is a pictorial representation of how Git works. So you have windows which show explanation of what each and every concept is. Like here we have Git commit, and like I had mentioned, so a commit is a snapshot of the current state. Like in cricket, you have the current score, or in Google Docs, like I have shown, the current version which you're seeing right in front of you. And what Git does is, rather than storing the entire state, it just stores the difference between them, which is called as the delta. That you can look here. So how commit works is, you start at a zeroed commit where the history starts, and then whenever you make a changes, you record these in separate commits. So let's just try this out. And our first mission would be to make two commits. So you can see the code here, and the current state is here. So we have two commits here, and our goal is to make four commits in total. So to make any commit, what I would do is I just type this command, hit commit. You see, as soon as I type this command, from the initial two commits that we had, we now have an extra commit which points to the previous commit, and this previous commit again points to the very first commit. So this is the initial commit. Normally, every commit has something called as a parent commit. So whenever you have a commit, you go to its parent commit, and then you go to that parent commit. You keep on going. So we'll reach the initial state, and this initial commit is a special commit in the sense that this specific one does not have a parent commit. So this is the initial commit is the beginning point of any repository. Back to our goal, we had to make two commits. So I use tab 2 to complete, and then once I make the second commit, so you can see that I have solved this one. You can move on and look at the other ones as well. But for now, I will just skip everything and get to the. Yeah. Now we'll get to branches. Yeah, here we are. Okay. So in the previous level, you had seen that we had two commits initially, and we had to we had to make four commits in total. And there was this little thing here called need, which is like the pointer to the current commit. So this pointer specifically is called a branch. So what a branch means is, it is a named pointer to one specific commit. So instead of saying C0, C1, C2, in big repositories you have thousands of commits. So you can't just keep on saying C 1127 or something. So you have these things called branches, and in normal development cycles that you would see on most repositories in GitHub, branches are branches follow this workflow where you have one branch, which is the main branch or the development branch, where the working or the formal copy of the code is stored. And whenever you want to make any changes to it, let's say you want to suggest some feature in the Linux kernel, or let's not talk about kernels for now. Let's just say you go to the Google Chrome repository and you want to make any changes to it. And you want to suggest these changes back into the repository and say that, hey, I want these changes to be reflected in everyone's version of code. So what you do is you go to that repository, yeah, make a new branch. Let's say I want to change the colors of Google code. So let's say I'll name my branch new colors. I'll add whatever changes I want, make it as a commit, and then I will do something which is called a pull request. So first, let's just go back to the initial steps. We have to make a new branch. For making a new branch, your command is get branch and the branch name. For this mission, we have bug fix branch. And see, there's this little star over here. So what this star means is whenever you're making any changes, right, the get wants to know where you want those changes to be made. So star represents the current branch that you're working on, or indirectly the current commit where you want the changes to be made. Let's say I want to start a bug fix branch, make changes to it. But I don't want the main branch to follow those changes until I am sure that these changes are fine. So what I'll do is I'll keep the main branch aside. I'll start working on the bug fix branch, make changes, make a commit, make more changes. And then once I'm ready with it, I'll bring these two together. This is how branches work. And to complete our mission and to explain how you change branches, you use this command. Checkout and branching. Okay. So in this mission, it is bug fix. And the instructions, okay, this is change. Okay, now this is done. I'll just refresh it. Sorry about that. So this is one of the questions which someone asked, and how to merge branches effectively. Although you might not see it here, but we will talk about this later once we get into the code part, where when two different people or more than two people are making any changes to code, so one person will be making changes in some part of the code, another person will be making changes in another part of the code. So when these two parts are completely distinct from each other, you can make the changes directly. There's no difficulties in here because what changes I am making does not affect this person's changes in any way. Logic difficulties come into picture when both of you are trying to make changes to the same part of it. That's when kid gets confused what to do because you are trying to introduce something, but someone else has already made a change. So kid is not sure whether your change should come before, after, together, or how your change works with respect to the other person's change. Okay. We will get to the tutorial again. Let's get back. So let's look at our goal once again. We have two commits. Then will be making one commit on the bug fix branch. Then we will be making one commit on the main branch. So if you see, main branch can either come from here or here. What we'll do is first let's make a new branch called bug fix. As you can see, a new branch is created, but the star is still on me, so I'll have to change it. Okay, take out. Whatever changes I make now will be affecting the bug fix branch, but the main branch will still stay the same. And this is how you can see. So when I do git commit, now you see that the bug fix branch has moved forward, but the main branch is still at the old version of the code. So this way you can make changes without affecting the working code. So now we have changes on the bug fix branch. Let's say I wanted to put in a new color. I've made those changes. Meanwhile, back at Google headquarters, someone found a security issue and they are trying to fix it. So they are on the main branch. Relate to the main branch. Let's give check out main. They fixed the security issue and they committed to get commit. So now you see Google has fixed the one commit which fixes the security issue. I have one commit which changes the color. Although mine is insignificant, I still want to include. But just because I want to change the color, I cannot, you know, tell them to ignore the security fix. So what we'll do is we will merge, we will stay on the main branch and then we will merge the bug fix branch. So since we are already on the main branch here, I'll just do get merge bug fix. So that completes our current mission. Any questions so far? I'll take a small break here. Okay. Looks like there are no questions right now. So now what we'll do is, okay. So now what we'll do is we will move on to working with actual code. And like I'm confused. If two different things are going, so how will it merge? We'll get into that. So we will try to introduce a merge conflict, which is I guess what you're trying to bring up. And then we will see how to deal with that merge conflict. So if you want, you can proceed in this website later. But for now, I will switch to GitHub and then we will start working with the code. So I'll stop sharing this screen. I will do my GitHub. Instead. And if you want to create a new repo, there is a shortcut called repo. But it also it just simply opens a new repository. So let's say I will create this repository called Git tutorial. And I want to make an initial commit. So what I will do is I will select one of these options for initialize the repository. So now this option will just add a README file, which is like a documentation or a user manual for the software which I will do. And what it does not do anything right now. What it does is just adds the repository name as the heading of the README file. So let's just go ahead and create this repository. Now you can see that I have this here. You can look at the list of commits. So you see there is an initial commit, and you can see that one file created. This was added, nothing was removed. Like I had mentioned initially, you don't have files stored as it is. You just have the idea of creation of files, deletion of files, and changes to files. Right. Now, what I got to know is most of you are either secondaries or thirdies, and I am hoping that you are able to understand C language at least, if not completely, but what I'm trying to do. So we'll just take a simple example and we will start with the code editor. So now GitHub has this useful feature where if you are on a repository and you want to make any changes, what you can do is when you're On this page, just click on the dot icon, and what you see is that it opens up a web version of VS Code where I can do whatever changes I want to my repository. So let's just say I want to add a new file. We'll start with a simple example again. We want to calculate the factorial of something. So I'll make a new file. I'll name it something, say fact.c. So now I have a C file. I make this here. I should take an input as well. Okay. And I'll start with the most straightforward way of doing it. If n is 0, then return 1. Else, return into factorial minus 1. Good. I've written this file. And what you can see is now there is this little tag over here that comes, which is called added. So Git has this idea of something called a working tree. So you have your regular commits as well, and you also have one pseudo commit sort of thing, which is your current state. So something which you're not ready to commit yet, it is called. It will be stored in this thing which is called your working tree. So let's just say before I make any changes, I will first make a new branch. So I'll go to source control, then create branch, and let's say first factorial. Branch. I have the option to switch to the branch.
Bhaiya, I have a question.
Yeah,
If I do everything you're doing in my terminal about the add section window, will it get saved before we add or after we add? Suppose I quit the terminal after I give the add command and the code goes to the add section. So will it be saved if I close the terminal?
it won't be saved. Let's
It
say
won't be saved. Okay.
I do something like this, which is what you're asking. So if I refresh and see, so there are okay, so it gets saved. We have made a new branch, but you see that the file which was added is not saved in this branch, so it does not get saved.
So it just gets initialized. Am I right?
Yeah.
Okay, all right.
So as we were doing it again, it is stored in the working tree. So in this case, your working tree is your laptop. What we'll do is we will get to source control. Now you can see down here that we are on this branch called first factorial, and I have these branches to change. What I'll do is in VS Code, I have this plus icon. If you're able to track my cursor and see that there's a pop-up for state changes. So what state changes does is it says that I want to consider these files and make a commit with these files. So I will stage this file and then I will write a commit message. So a commit message is like a comment on what you had done at that point in time whenever you were making that point. So what I did here was I added a new file which calculates the factorial. So I use initial factorial. And there it is. I commit and push. So now you see it has been removed from add. We go back here. You can see that the file is shown with normally there are no extra tags attached to it. We did this change in the first factorial branch. Now here if I go and go back to the main branch, so what you will see is that This file is still not saved. It has that add tag. And if I remove this here, let's see from here also I'm delete it. Even if I delete it here, I go back to the first factorial branch and the file will still be present. So these changes which I made now are present in the first factorial branch, but not on the main branch. And another thing is, if I look at the commit history, you see the commit history here. Okay, I will show the commit history on it. I go back to the tutorial. So you see, even though I'm on the main branch, I get this pop-up that there's a new branch. It you have made changes to it recently. So you want to add these changes back to your working copy. So what we do is we will do compare and pull request. So since there's only one commit, GitHub fills up that commit message as the title of the pull request. If I want any extra details to be added here, I'll add them. And then to create pull request. Let's leave this open for now, and we will go back to the code. We will change our branch to post factorial. So now you see that first factorial has two commits. So there is the initial commit, which was present on the main branch, and there is the factorial implementation that we just did. Again, switch back to main branch, there's the initial commit. So we go back to first factorial, we open up this commit, and you see this is how get shows the new file. So there is a file called fact.c. These green lines represent additions. So these four lines were added to a file called fact.c. And if you look at the right side, you see the commit hash as well as a thing called one parent. So what one parent means is which commit this one had emerged from. So if I click on parent this, so you see the initial commit, zero parents, the commit hash, and this was one. So we go back. Then as I said, let's try to introduce a merge conflict. So I start working on the factorial implementation. Then someone else starts working on it at the same time. So they do not know that I am working on my factorial implementation. So they do not know the existence of first factorial. What they know is main branch is there. So let's just say my factorial. My factorial, and I will create it from the main branch. Okay, switch to this branch. I also get the same idea. Let's just name it fact.c because four-letter word and it defines what we are doing. So we are on my factorial. I do fact.c. Again, I make the same changes, but instead what I do is in fact because I want to have different names. Then again in third and do the same thing. If n is zero, return 1. Else return so the future. I'll go back. I'll stage this. I'll write a message. Factorial implementation. Button push. Then I go back. I have pull, I have this pull request open as well. So I'll make a pull request. And now you can see the same thing which has come here. So you have this commit. If you go to my factorial branch and you look at this, so this also has two commits. Then you go to this commit, see the same parent that was there for the initial factorial. So this is happening in your own development workspace. Let's say you're working on a team and you're working on your own part of the code that you're assigned. Now the team leader comes around and he wants to integrate these changes into the main code. So he starts with the earliest code request. So we have initial factorial implementation. Have a look at it. Okay. Merge pull request. Looks good. This has been merged. So the first implementation was merged. Now we come to the second one. You see that this is where we have merge conflicts. So we have the same file, and what we have is if we open the web editor. So now this is where the issue comes in. We have the beginning of the file. Someone has written int factorial. Someone has written int fact. But otherwise the code is, even there are minor changes here. Like this, there's no space here. So this has been recognized as a different branch. And since this is factorial, there's factorial here. This is fact, this is fact. Otherwise, the closing curly bracket was the same. So get decided is to look the same. We can merge this and have a single copy. So what do we do about this? What you do is you select the one which is better. In this case, factorial is more comprehensive about what it does. Fact can mean anything, so it can cause confusion. I will delete this and delete this, and then I'll delete this pointer as well. So I will factorial, and I can do mark as result. So commit merge. Now this can be applicable for small fixes where you know you have only one or two issues that you're trying to merge. When you have bigger files where there are hundreds of lines of code, then what do you do? So let's just take this main branch followed by a few more commits where we improve on the working of this factory. We go back to main branch. And here you can see that we have a fact.c. Then let's say I want to improve this and recalculate some extra things. So what I do is again go to source control, branch, create branch, and I call it first file. Switch to branch. So now I'll set up some more initial conditions. That's because I know that I know 0 factorial, I know 1 factorial, I know 2 factorial. So I can go up to 5 factorial and define it. And that way what it does is at least until 5 factorial it does not have to sit and back calculate more things. I'll go back to the file. Let's copy this. Stay here. Make this else. If I need equal to 1, I can return 1. Or if I use the shortcut key to duplicate lines, shift and the respective factorials. 6, this is 24, this is 1. Nice and good. Now you see modified. So what modified does is you have this staging changes right in your pseudo command. So modified means what you have done to the file is you have changed the contents of these files. So if you look at the working tree, You can see that there was nothing initially at this side, but here I have added new changes. So modified, these changes were added. Okay, sounds good. And add this, make the changes. That's good. And you can push. If I want directly, I can go to main branch and probably perform a merge right here instead of going to the hassle of a pull request. Doesn't look like I can. Again, have to go faster back, create a pull request, and just merge it. Now a third person comes along. And what this third person does is, this is the current state of me, but they were not paying attention to this. They were at a point where main was, here. So let's just say I create a branch from for the better factorial because instead of doing recursion, we just sit and calculate it on a for loop. And what we will do is, I saw the first factorial implementation. I switch to this. And then I go back to factorial and I say, let's not do all this. We'll do this. Let us that is equal to 1 and 4 is equal to and this one. Then this standard shape. Simple planning and this slightly the shorthand notation. Fact is equal to fact into n and return. Okay. So I have these signals in mind. Can add if you want to look at the differences now. So you see that what has been removed now is shown in red, and what I have added is shown in white, green. What I'll do is I'll just make this a factorial and I comment and push. Now go back to GitHub again. Let the factorial had some changes, cannot automatically merge, and there's a conflict in factors. So one other thing is, let's just have a look at our commit tree once again. So if I go to insights and there is the sync on network. So network does shows your commits as a horizontal tree. So I had a first factorial branch which I merged. Then I had my factorial. And I merged the changes from the main branch into my factorial. Then my factorial was merged back into main branch. Then faster factorial comes along, adds changes, merges it back to main branch. Now main branch wants changes from better factorial. But if you go to the pull request, you'll see that these changes are this cannot be done automatically by since there are conflicts involved. So what we will do is the one advanced way of merging branches, which is one of the questions that you guys asked. How do you merge branches which are completely different from each other? So for that, what I will do is I will clone this repository You can use either HTTPS or SSH, but when you will follow along, you will need to use your GitHub credentials to connect to this. So what I'll do is I will open my, then I will change to my mutual development folder. I will clone this repository. Clone repository name. So you can see it's started to. When I'm cloning this repository, what I'm doing is I'm making a copy of the entire repository onto my laptop. And now if I get into that folder, say CD git tutorial, you can see the I guess second I'll just change this. Okay, my entire screen is open. So you guys are able to see the commands that I've used to copy the repository into my laptop. So this was the command I just showed to you again. So it is git clone. Then back to the repository, I made this copy. So I copied this here. Let's see this one, whichever it is. And what you do is separate git clone and then you paste it. Once you press enter, it will make a copy of your repository which was created on GitHub. Then it will be the same name as your repository name. So since it was under my username as Git tutorial, I go into the folder Git tutorial, and then if I want to open VS Code, I use the VS Code command. For current folder, it is code space dot. So I do code space. Now you see this is my local VS Code which is open here, and I have these branches. So if you're able to see through the contrast, then this is the branch that I looked at factor. And this is a little bit more contains and stuff about the comments. So in the comments on this side. So now you can see that there are three commits on the branch better factorial. So there's initial commit, then there is a commit from first factorial which we have merged, and then there is the better factorial which we are working on. So what I'll do is I am going to check out first check out the fact. Since I already changed it in VS Code, I don't have to change it again. Now if I want to merge my changes onto the main branch, first what I will do is I will do this thing called a rebase. So what rebase does is, if I show you the pull request, okay, you see that better factorial has one commit which is not present on the main branch, but main branch has moved forward from it. So essentially what I'm doing is this commit which started from some older commit in main branch. I want to make it start from a newer commit in the main branch. So then I use this command called rebase, and the format goes something like this. First, you check out the branch which you want to merge into main. Then you do git rebase. Then you put a hyphen I for interactive, and you select the branch which you want to merge into. In this case, our main branch. So when I open this, you will see you will see something like this actually. So you see the single commit which is unique only to the factorial branch, which is not present on the main branch. And get wants to know what you want to do with this commit. So what I and if you look at the options here, there is use commit, then use commit but change the description, the commit message, edit the commit. Let's say you have 3, 4 different commits and you want to make them a single commit, which is how some repositories have a workflow sort of thing. So you can do all sorts of advanced stuff this way. For now, what I want to do is just take this commit, try to integrate it into the main branch. So I will just, it is the default option. So I will close this. And so now you can see that it is trying to auto merge the main branch into the first, it will merge the main branch into better factorial, so that whatever changes are on main will come into better factorial. But once it has done that, then it will try to do the changes which I did on better factorial. So in better factorial, I made these changes, but in main branch, it has found these changes which were not present initially. So now VS Code has given me this more, let's say, elegant UI on how I want to integrate these different changes. So you have the current change and incoming change. You don't have to worry about which one is which. You can just read which is mentioned as the current, which is mentioned as incoming. So since I want my changes, so I'll click on here, accept incoming change. And once I do this, you'll see that I have this message. Resolve all conflicts manually. Mark them as resolved with git add /rm conflicted files, then git rebase continue. So now these changes are there. I will add them and then I will continue the rebase. So once I finish the rebase, continue. I will go here. Rebase, continue. It will ask me if I want to change the commit message. I don't want to, I'll just close it. Now you see that successfully rebased and updated the references. So it has updated the pointer for the better factorial. And now if you look at the list of commits, you can see that better factorial is present again, but now it is preceded by different more commits. So initially it started from this place where it was the initial factorial implementation. Then all these changes were incorporated. Now from this point, I tried to make this better factorial change, which has been which has been made successfully here. So once I do this, I will have to push those changes back to GitHub. So when I do push, what I'm doing right now is whatever changes I did on my laptop, I want them on GitHub. So I'll do git push, and it will fail because if you do push normally, what it does is the tip of your current branch is behind its remote counterpart. So you started out with the main branch, which was common. Then GitHub has one copy of Better Factorial. You have another copy of Better Factorial. Now again, Git is confused whether to use this or this. Now we know this is useless, and this is what we want, where we have more comments here. So we'll just forcefully push it, and we will do git push again, but with the hyphen f. Duplicate my connection. Force update. So now this has also been updated. Gautam,
Rishikesh, your internet went for a few minutes, for a
acha,
few seconds actually.
at what point did you lose me? So we'll just
Just 10 15 seconds ago.
Yeah, just like 20 seconds ago.
okay. So I'll just so what I was explaining here is so git push, as I was saying, is whatever changes were on my laptop, I want them on GitHub. But then GitHub has this one copy where there's one commit from some older point in main branch, and I have added a few more commits in between. Then I made these changes. So you see that there's a sort of branching happening. Normally, a single branch goes in a linear fashion. The entire Git can work with different branches, but our single branch, which was better fact, is try has diverged into two different points. So what we do is we will force GitHub to accept our laptop's copy as the original one. So when I do push, I'll include a hyphen, and then once that succeeds, you can see in the bracket that this was a forced activity. So coming back to better factorial, and if you look at this now, so now these were the changes that were actually made. And if I go to better factorial and get the commits, so now you see that initially when we started better factorial, it had three commits: initial commit, initial factorial implementation, and better factorial. But by the time I was able to get this better factorial back into me, few more extra things were added, like these my factorial implementation and everything. So what I did was when I did a rebase, I took the extra commits from better factorial, changed the arrow to point to the top of the main branch, and then once I do that and go back to the pull request, so you can see that there is only one commit which is different, and now I'm able to perform this pull request without any issues. So this is a successful merge. More or less, this is what you would be doing with Git in general. I go back to the main branch. You can see, fact, let's see, this is present. That is it for the tutorial. And I will take up any questions with Pranay. Is Git a language used for performing tasks in GitHub? So Git is a software. If I get into the technical terms, Git is a distributed version control. And what differs from say Git and the previous example in Google Docs is when you open Google Docs, right, initially you will only have the current version of the file. You won't have the complete history of the file until you go and open version history. So if you do this little experiment where you open Google Docs or some doc which has been edited for a lot of times, turn off your internet and then try to open version history, you won't be able to do it. But Git on the other hand is able to track your changes even without internet. So what GitHub does is it is like a common place where you post these repositories. So I make changes, I push to GitHub. Then someone else wants these changes, they will pull it from GitHub. And GitHub is just one example. There are different Git hosts. There is GitLab, there is Git Bitbucket, there's even Atlassian. So GitHub is just a Git host.
Guys, do you have any questions, or like should we call it a wrap, guys? If anyone has any question, just unmute and ask.
You can even ask it in the chat box or raise your hand or ask.
So I guess with that we can wind up the session. Thank you for Rishikesh and Pranav for this wonderful session, man. It was actually really informative, and even I could learn few stuff from you guys. So thank you for coming, and thank you for taking out time from your quite busy schedule, I guess. Thanks a lot.
Sure. Thanks a lot, Tom, and good, good evening to all of you.
Hopefully it was great for you guys. Yeah, so with that we can. Yeah. Also, the recording is gonna be uploaded soon. So if your friends have missed this session for some reason, you guys can see it from YouTube from CT's channel. Okay. With that, we can end the session. I guess. Yes.